The changes in the technology away from the established players, the big space agencies, to someone like SpaceX who can revolutionise the launch industry, and now we see the new space entrants arising a lot out of the CubeSat work done in academia, really transforming the Earth observation business with Skybox and others coming along behind them. Really starts to change the barriers to entry for this for the industry. We're now going to hear a presentation from Dr. Jeff Colton. Jeff Colton is a senior lecturer at the UNSW Australia Business School. Before joining UNSW, Jeff was a lecturer in the School of Accounting at UTS, and prior to that at the University of Sydney. In 2006, he was teaching at the University of Texas at Austin. Jeff worked as a solicitor for Cause Chambers Westgarth for a number of years before returning to academia. Jeff's research interests include voluntary disclosure, executive remuneration, corporate governance and earnings management. He's published articles on earnings management, the disclosure of executive compensation and corporate governance. Jeff's current teaching interest is in the area of financial statement analysis, focusing on business strategy analysis to inform the use of accounting information and other public disclosures in firm valuation. He also has experience in teaching financial reporting courses. Welcome, Jeff.
Well, thanks for having me here this afternoon. So yeah, I'm coming from what's obviously a non-engineering and a non-mining specific background. I got involved in this area with some of the work. Got involved in this area working particularly with Andrew Dempster and Serkan Sadem. When we're doing some work involving in the economic feasibility of various off-earth mining projects. And one of the things that we thought might be interesting was to see how a group, not just similar to what Chad was doing in his talk just then, see how a group of MBA students might approach a valuation task. One of the courses that I teach at the Australian Graduate School of Management, the AGSM, is a financial statement analysis course with a particular focus on valuation. So a term project for that type of course is going to be something like, do a detailed analysis of Walmart and tell me if you think it's overvalued. Do a valuation of Qantas, tell me if you think it's a good investment or not. So we thought we'd do something different, or give the students the opportunity to do something different and try and do a set of forecasts and valuation of various off-earth mining projects. And we thought this would be a good opportunity for a couple of reasons. The first is that MBA students are typically telling us that they don't want to do textbook projects, but they want to do something that has sort of real application. Other than textbooks, the other common place where we get material for them to study is from written case studies from, say, Harvard Business School or Wharton. And they've done Harvard business cases to death, so we thought this would be a neat opportunity for them to do something different. The other reason why we thought it might be useful is that our MBA students at the AGSM will typically want to work in one of two places when they finish. They'll either want to work for a consulting firm, McKinsey's or Bain & Co., or they'll want to start up their own business. Both of those jobs involve forecasting under uncertainty, and sort of that's where my teaching is focused, so trying to get them to do better forecasting. So off-earth forecasting, or off-earth mining, is obviously going to be an extreme version of this forecasting under uncertainty. So for a number of reasons, we thought that it might be a neat opportunity to see what the MBAs would come up with. These are students that, some of which have some engineering background. Our cohort will typically have some computer engineering students and some IT related backgrounds, various other finance and other industry backgrounds, but they're not mining engineers, they're not electrical engineers, they're certainly not space engineers. So these are students that are coming to the game with very little technical background, about the same technical background that I had. The projects that I'll talk to you about, three of the projects that the students ended up selecting. We had two near-Earth asteroid mining projects that two different teams were taking two different approaches, and a moon mining project. Andrew Dempster came along and talked to the students at the start of the semester and gave them some technical background. We gave them some background materials that they were able to work off that helped them on the technical side of things. But by and large, from the technical things, they were then self-dependent, so they did a lot of their own research from there. So I'll give you a summary of kind of what they were looking at, the assumptions that they were making, focusing in particular on what they thought might be the expected capital expenditure and the expected NPV of the projects. And the first of the projects that they were looking at was trying to set up a mining industry. And we heard about Ceres earlier on this morning. So, and I guess part of what they were doing with these projects is that the students were told to assume that there was technical feasibility of these projects, which I guess is important. So in a lot of cases, there isn't yet technical feasibility for a lot of what they're assuming. So they're working backwards from what the engineers might typically do. So rather than saying, can we do it, these students were, assume we can do it, how much is it going to cost to do it, is really where we're coming from. And I'll explain why we took that approach later on. So what they were planning on doing is mining Ceres for both water and to process the water into its component parts to on-sell the hydrogen and the oxygen. For those of you that aren't aware, this asteroid, as I understand it, is a pretty good candidate for this type of operation. It does contain enough frozen water to support some mining operations when the technical capabilities are there. It is the largest asteroid in the inner solar system. So a good candidate asteroid for some mining exploration activity to work on. And the study showed, approximately 25% frozen water. So it could work nicely in this context. The students will give us, again, for those from the mining engineering side of things, a typical flow chart where they were trying to map out what the phases of the process were, what those costs would be, what the expected revenue might be. And again, the main revenue item was obviously going to be the selling of the output, the water and the component parts. Interestingly, they were also focusing on, being good MBA students, were focusing on some ancillary, so advertisement, tourism, broadcast rights, satellite. They're trying to think of additional revenue points that might work in this type of setting. The CapEx that they came out in their base case was predominantly getting the mining equipment, the 3D printing that they were going to use to establish the mining process, and the robots that would assist with all of this. The CapEx that they came up with, including the launch cost to get them there, was going to be about $27 billion. Okay, $27 billion. And out of the kind of three projects that I'll talk about this afternoon, that was, by some measure, the largest capital expenditure. Given some of the numbers that we heard sort of Robert and Renee speaking about earlier this morning, that number doesn't seem too outrageous. They were the things that were going to be driving, I guess, that is, as I said, in particular, it's the launch costs of getting the equipment up there is going to be the expensive part of it all. And of that, the mining and the robots, they forecast to be about $20 billion. The 3D printing they assumed was going to cost them $6 billion to get up there. The assumed launch costs for those interested that most of the groups were using was just over $10,000 a kilogram. So that was like where that come from. So just over $10,000 a kilogram is the assumed launch costs. So I said, on the revenue side of things, they're forecasting over a 20-year period, and they were forecasting this as a single project. They were assuming that this wouldn't be an attractive proposition to any lender, so there wouldn't be any borrowing involved, which I think is a relatively safe assumption. The primary sale, as I said, of the output was at $4,000 a kilo, the water and the components. They came to this number on the basis of what they've calculated as a break-even price on their base case, and they had a markup on that. And again, we've heard from this morning about a number of different ways that we could come to a pricing model. And again, they weren't pricing this to get it back to Earth. It was for use out in space, so for use out in particular on Sirius. $4,000 a kilo. The volume that they were assuming was that they were going to be able to assist in the refueling of 10 space trips per year and 100 satellites per year, and were able to do that over a period of 20 years. So I said there was some very minor revenue that was coming from advertising, from potential space tourism. That project came out with positive NPV of about $77 billion. One of the things that drove that was the cost of capital that they assumed. The discount rate was 20%. What they found was that, and each of the projects gave us some nice looking spreadsheets where we could adjust all of the parameters. You can see particularly the NPV is wildly dependent on the discount rate that you use, and that was the case for all of the projects. They were assuming 20% gave them a reasonably good NPV. Once we get into those higher discount rates, we start getting a close to zero. 48% in the base case was the break-even. Obviously, some of the changes in other input prices, oxygen and water, was going to be dependent too. But for a CapEx, so CapEx spend of 77 was the return. The second model that we were talking about was mining on the moon. This was to, again, water and fuel was the output for space agencies, for space travel, and for satellite operators. They assumed, as did the Ceres group, that they were going to be able to be, in effect, price makers, that they would be the only people doing this. The output they were going to do, they were selling this, they were going to be initially doing exploration using sort of NASA lacrosse type, or the L-cross type equipment, and the CapEx spend from the materials that they had here was going to be, in this case, $9 billion as opposed to the $27 billion that the Ceres group had. So $9 billion was to get, it's the use of the L-cross technology. They're assuming that for transportation purposes it will be the SpaceX Falcon Heavy, and sort of $2 billion each was the assumption for the water extraction machines, electrolyzers, reusable water tankers. So again, largely this was driven by the $10,000 a kilogram launch cost. Assuming that they'd be able to sell the 250,000 kilos a year of fuel, and this is from out at 2035, that gave them an NPV of negative 420 million. Okay, so this is a loss-making venture over a 50-year project. Cost of capital of 24%, and so if we up that cost of capital or the discount rate to get us into sort of present value dollars, it's going to be even more of a loss-making venture than that. Whether they're going to be able to sell the $250,000 a year, 250,000 kilograms a year from 2035 is one of the assumptions that I guess is questionable. If they're able to go 50% higher price, 50% higher volume, then they found this to be a kind of a profit-making venture. The final project was, rather than mining on an asteroid, was to take material from an asteroid and bring it back and process it in low Earth orbit. And space missions, space stations, and space tourism will be able to use the output of that type of process. The capital expenditure on this third project, I think they're understating it, although some of the work that Chad was talking about says that the CapEx might be coming down. 492 million, and again, by and large driven by launching equipment. The spacecraft, the drill unit, along with the storage equipment. Higher cost of capital, 40%, declining at 25% once production commenced. They were assuming a sales price based on expected launch to geosynchronous orbit in about 2035. So they thought a fuel price of $3,500 a kilo would still be less than the launch cost at that time. So the 492 gave them a 259 million. And again, discount rate was the thing that the valuation was most sensitive to. So the takeaway that they got from this was that discount rate matters, selling price matters. So as a good consultant, I'd be able to give you an NPV and give you the costings that you want. But I guess the importance of all of this is that once we start narrowing down the technical specifications of any particular model design, then we can start narrowing down the variability in the numbers that we'll be getting out of all of this. And so that's kind of where it's led to some of the work that I've been doing with Andrew Cirk and Robin Rowe with the NASA JPL people on the in situ resource utilisation in Mars project. So I guess from a question perspective, I'd be interested in what you guys think would be an appropriate discount rate to use for these types of projects, because that's something that the students kind of struggle with. One of the reasons being is the typical way of estimating a discount rate from a finance perspective is difficult to apply when we're dealing with something like mining in space. It's just difficult to work out what the discount rate should be. So certainly if you've got any feedback on that, I'll be happy to hear it.
Questions for Jeff?
Hi, I'm from the Centre for Exploration Targeting, so I just thought I'd ask, when we value long-term projects in the exploration industry,
Yep.
we use expected monetary value, not net present value, is a component of expected monetary value. I'm just wondering, these projects are so dependent on sort of major uncertainties, would it make more sense to have some kind of valuation technique that basically looks at the whole range of NPVs and the likelihood that you're
Yeah, and what I didn't...
kind of positive return? That seems a more really, interesting plan.
Yeah, and what the students were kind of doing is ended up doing kind of like a Monte Carlo simulation where you get your distribution of outcomes. The reason they were kind of in effect instructed to do an NPV type analysis rather than expected is that they were, to make it equivalent to the typical project they were doing, is put yourself in the position of advising a potential investor in this type of project now. That was kind of the context in which they were given the projects.
To me, this is analogous to investing in exploration in a sense, which is the minerals exploration, which is a kind of long shot type business, right? So the business case for valuing exploration isn't the ultimate value of the mine that's 10, 20, 30 years down the line. It's the probability of doing something that works and does have a value add versus the likelihood that it's not going to work, which is sort of main multiple of that. And it seems that kind of technique is more better for these long-term things. That's why I would take it if I was taking your... Yeah.
Hello, I heard you mention there was a certain level of fear about dealing with things out there where there are so many unknowns. What would be, whereas they may not have had that fear dealing with an on-Earth mining project perhaps, what do you think the cause of that hesitation was?
That was something that surprised me, and I expressed that surprise to Andrew over the course of the project, is that these were students that I thought would be the most likely to embrace this type of the unknown, given that a lot of them wanted to do that as their job, to start up their own businesses or advise companies that were starting up their own businesses. I suspect that we would probably have more traction running the project kind of next year, given what we've had in terms of the publicity, in terms of the work that's been happening in relation to both Mars and NASA's kind of the publicity generally. I think there's just been an increase in the awareness that we could probably sell to them. But that was something that really, probably the biggest surprise to me was the concern they had about this valuing extreme uncertainty. I didn't expect that from that cohort of students.
Did any of the students consider projected possible future value of licensing?
Yeah, there were a bunch of ongoing things that they could do. So the value of your expertise, the value of any IP, the salvage values, all of those sorts of things were they were a minor component at best of what they did in the valuation exercises. But yeah, there were plenty of things that they could have included. That again, were we running it again, we would give them I guess a lot more material to start with. Yeah. Yeah.
Thank you, Jeff, for that. I know we've still got a couple more questions. Maybe we can deal with those during the break.
Absolutely.
Thank you, Jeff. Great presentation. Very interesting topic for the MBA students to get their heads around.